In this video, we're going to look at solving quadratic inequalities. So we've got x squared minus 5x plus 6 is greater than 0. So what we do first of all is factorize the quadratic. So we know from before that the plus at the end means we're going to have the same signs in both brackets. So we can say the same signs in both brackets. And in our case, it's going to be a minus in both brackets. So two brackets like this, minus here and minus here. What two numbers times together to make 6? That's 3 and 2. Minus 3 minus 2 definitely make minus 5. So we get x minus 3 and x minus 2 is greater than 0. So what we do when we solve this, we can say x minus 3 equals 0. So we can add 3 on both sides. So we get x equals 3. Or x minus 2 equals 0. So we can say that x equals 2. But these are called critical values. That's where, I'm going to write CV for short, critical values. That's where it crosses the x-axis. So when we draw a graph, and it's very important you always draw a graph like this for a quadratic inequality question. They're both positive x values, so the quadratic graph is going to cut the x-axis like so on the positive side. So that's 2, that's 3, then we've got a 0 here. Now whenever it's greater than 0, the y curve is above 0 here. So this portion of the y is above the graph, but we're not interested in y, we're interested in the x value. So we're going to shade everything to the left of that region, like so, making sure it's above x equals 0, because it's got to be where y is positive. So all the x values here in green we shade, and then we shade this portion of the graph, so it's all of that. So we always shade towards the left of the curve and shade towards the right, provided that we're greater than 0. So the way we describe this, anything going towards the left of 2 is x is less than 2. Anything going towards the right of 3 is greater than 3. So we say x is greater than 3. So we say x is less than 2 or x is greater than 3. So we know that this is meaning we're going to have different signs. So we're going to have two brackets like so, x in one, x in the other. One's a plus, one's a minus. Well, 6 times 3 makes 18, but remember about the signs, that minus means that it must belong to the bigger number, so meaning minus 6 plus 3. So we're going to get a plus 3 and a minus 6 here. This is greater than 0. So what's going to happen here is we're going to solve this. So we say x plus 3 equals to 0. So that gives me a critical value of x equals minus 3, or x minus 6 equals 0. Solve this, so we get x equals 6. Now, when we draw our graph, notice this time, one's negative, one's positive. So the curve will go like this. So that's 0. So this is minus 3, and this is 6. So remember, we want to shade towards the left of minus 3, all of this, and shade towards the right of positive 6. So the way we describe that inequality is we say x is less than minus 3, or x is greater than 6. Here's one more question for you to try on these type of questions. Pause the video. When you're done, I will go to my work solution. Okay, welcome back. So plus at the end means the same signs. So we're going to have an x minus here, an x minus here. 8 times 6 is 48. So it's minus 8 minus 6 definitely makes minus 14. this is greater than 0. So we can say x minus 8 equals 0, or x minus 6 equals 0. So we can say x equals to 8 or x equals to 6. These are called critical values. So again, they're going to cross the positive side of the x-axis. So 6 goes there, 8. We want to shade towards the left of 6 like that, and the right of 8. So we can say that x is less than 6 or x is greater than 8. Okay, and for the last type, whenever it's less than 0, the rule's slightly different. We factorize it as normal, so we say different signs. So different signs here. Now we're going to have 1's a plus, 1's a minus. So now we take the factors of 48, 8 and 6. The plus here means it must belong to the bigger number, so it's plus 8 minus 6. It's plus 8 minus 6 here is less than 0. Solve that quadratic, x plus 8 equals 0. This gives me the critical value of minus 8, or x minus 6 equals 0. So x equals to 6. Now, one's positive, one's negative. So when we draw a graph, it's across the negative and the positive axis of x, meaning this is minus 8, this is 6. But when it's less than 0, we shade the bottom part of the graph here in between the two values. And the way we describe this in a certain way, we say that x is greater than minus 8, but less than 6. It's very important you read this correctly. X is greater than minus 8, but less than 6. Here's another question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So, again, same principle, different signs. So, one's a plus, one's a minus. This time it's less than 0. So 4 times 5 is 20. We've got a minus in the middle, so it's going to be minus in the 5 plus in the 4, and that makes minus 1. Don't forget this is a minus 1x, so we get plus 4 minus 5. So we get x plus 4 equals 0, or x minus 5 equals 0. These are the critical values, remember? So x equals minus 4, or x equals positive 5. And we call this the critical values. So you make sure you remember that, please. They're not the solutions, they're the critical values. So now we're going to then draw the graph. And you must always accompany a graph here in these questions. One's positive, one's negative. So we get minus 4 here, positive 5. But remember, we're less than 0, so we're going to be below the curve. So you shade this part here. All of that gets shaded. And then we describe it like so. We say x is greater than minus 4, but less than 5. So I'm going to write it in words so you remember it. We say x is greater than minus 4, but less than 5.